Well, I guess we can go ahead and get started, and we're recording, so we'll have this link up for us all. Um, so just to kind of give a welcome and opening, we'll introduce ourselves. We have a bunch of new members, which is very exciting. So just give an overview, and then we will introduce Dr. Hurford and have him speak. And if you think of any questions along the way, you can put them in the chat. And we're really hoping to have time for questions at the end. I know he's very excited to answer questions, so we appreciate that too. And if we don't have time for all questions, we can definitely get back through the group and things like that. So we want to welcome everyone. And as many of you already know, we created our own state chapter from the larger group called The Science of Reading What I Should Have Learned in College. And that group was created by Donna Hyde-Manick in August of 2019. And then our hope in creating the Kansas chapter is to just focus on local initiatives. So we've been really blessed to have local speakers and lots of interaction with what's happening in Kansas. So that's been awesome. So we'll just ask that you remain muted while Dr. Hurford is speaking, but definitely if you have any questions, like we said, you can put them in the chat and we'll watch those. And we definitely want to have time for questions, but we'll get back to those if we need to. So we'll just take a couple of minutes really quick to introduce ourselves in case there are any new members that haven't been introduced to us yet. So I'm Tiffany Seaman. I am originally from Wichita, Kansas, and then I attended the University of Kansas for elementary education, special education, and so I remained in the Kansas City metro area. After that, I was a special education teacher, a first grade teacher, fourth grade teacher, and then a reading specialist before moving to Boston last year. So we were there for about 16 months and moved back home, yay. So that's one great thing about the pandemic, we got to move home. And then I am currently homeschooling my three kiddos who are 4, 7, and 8. And they'll be returning to public school next year. So just since I was home, I stayed home with them. I'm excited to be teaching my first continuing education course through Baker this summer, focused on the science of reading. Just extremely passionate about advocating for literacy. And I'm honored to be part of this group with Gina and Renee. So I will turn it over to Renee and she can introduce herself.
Good evening, everybody. I am Renee Hopper, and I'm in Wichita, Kansas, and I work for Wichita Public Schools. My title is a lead coach. Basically, it means I do whatever they tell me to do. But we've been focusing a lot on word recognition in the early grades, K1 and 2 this year, and putting in place some different practices. So that's been exciting. I'm also a native of Wichita and the mom of 2 boys, 18 and 15. And my 18-year-old was diagnosed with dyslexia, and it gives me a real personal passion for this work and advocate for our kiddos from a parent perspective as well as a teacher perspective. So that's a little bit about me.
Awesome. And then we will have, thank you for sharing, Gina, go ahead and introduce herself.
Hello, I'm Gina Shute, and I am also working in Wichita. I am a colleague of Renee's, and so we have the same job title, supporting coaches and principals in literacy this year. And it has been just a lot of fun to be able to work alongside teachers, coaches, and principals and helping to meet needs of kids. And so this is my 26th year in education. And my kids are all grown and out of the house. And so I get to really pour into some of the things I love to do, which is being part of this group, which is so much fun, just to see teachers and educators connecting from across the state to be able to do whatever it takes to help kids learn how to read. So it's just a lot of fun to be here. And thank you all for joining us tonight.
Yes, we thank you all. Okay, well, I will go ahead and introduce our special guests for this evening. We're very excited to have Dr. Hurford, and I'm going to read kind of your bio, but if you have anything that I left out or you want to go ahead and add, please do. So Dr. Hurford is a psychologist and researcher who specializes in dyslexia and reading difficulties and attention deficit hyperactivity disorder, ADHD. He is a professor and chair of the Department of Psychology and Counseling at Pittsburg State University and directs the Center for Research, Evaluation, and Awareness of Dyslexia, Center for Reading. In addition, he is the president of Reading Screening LLC and the manager of the Center for Assessment and Remediation of Reading Difficulties, Inc. It's a mouthful, which is a nonprofit created to help individuals become competent readers. He was also a Spencer Fellow of the National Academy of Education. So we are so excited that you are joining us tonight, and we appreciate learning and growing from you.
Well, thank you. Well, I'm really happy to be here, so I appreciate that. I'm going to share my screen with you. And I like your little logo on your new shirts, man. That's pretty sweet.
That's awesome. Thank you.
Yeah, I'm liking that a lot. And, you know, one of the things that I've noticed when I first started doing in-service training with regard to reading issues a long time ago, as I said, I've been here, I think 34 years, somewhere around in there. I started doing in-service training just a few years after that. And when I would talk to them about the issues that were going on with children with reading difficulties, number one, they were surprised. And number two, they were very angry at the end. They were angry that they didn't learn this while they were in school. And so, you know, I love the notion of, hey, what things I didn't learn in school. So the things that you guys are doing is great. You're communicating with each other, you're getting ideas. I've been doing this for a long time, obviously, but I consider myself a student of dyslexia. I know people say that I'm an expert, all right, but I consider myself a student because there's so much more that we need to learn. Now, granted, we know enough right now to help kids become competent readers. I don't mean that we need to figure this stuff out. We've got it figured out. We've actually had it figured out for a couple of decades. And one might even argue for 100 years. I don't know if that I'd go that far, but Samuel T. Orton, who is a neuropathologist and psychiatrist, who actually studied neuropathology, and he was quite interested in what was going on between clinical behaviors and neurological differences. And so he looked at brains after the person died, obviously, because they didn't have imaging techniques like we do today. They had, I don't know if you've ever seen x-rays back in those days, but they're pretty horrible. They didn't really show you much, and the soft tissue stuff was just completely blurry. And the last guys I spoke to were in a sorority, and they were, all of them had been retired, and they're all 65 plus. Some of them could remember that in the 1950s, they actually at shoe stores would allow you to take an x-ray of your foot when it was in a shoe. I mean, the crazy things we used to do, right? Not a smart idea. And so Orton, he was looking at these differences between people's brains and their behaviors. And he got interested in this one kid that was 16. I mean, I'm telling you a really long story, kind of short, because there's a lot of other things I want to talk about. But he met up with this 16-year-old named M.P. because back in those days, they would talk about patients, but they'd only use their initials, which is a good idea. And it was curious because this 16-year-old knew all kinds of stuff. He knew how to take apart engines and put them back together again. He's very knowledgeable, but he couldn't read. He couldn't read a lick, even though he spent considerable effort trying to. And so Orton was like, now this is really interesting. I want to know why this is the case. And so he started looking at some things and thought that certain parts of the brain didn't communicate well with each other and didn't do some things very well. And he was right about that, as we know now. And Anna Gillingham, who is an educator and a psychologist, wrote with him the first manual to help kids become competent readers who had dyslexia. And that's now known as the Orton-Gillingham approach, right? OG. Now, we're going to talk about some other things in between talking about Orton, although Orton is one of those individuals who you read about him and you're just like, how did he figure this stuff out? I mean, really didn't have fMRI stuff, didn't have PET scans, it's just amazing. He had to crack open their skulls after they died and look and see what things didn't seem to be working right. And what's strange is when he looked at, individuals' brains who had dyslexia, he couldn't figure out what the difference was. So he thought it was kind of developmental. Of course, he wasn't right about everything. And how could you be, to be honest with you? So these are some characteristics, obviously, of dyslexia, which I don't know where everyone is. So I thought I would give you what I think is the baseline, what people need to know. So this is 2 hours of what I think you need to know as an introduction to this. Some of you guys are well beyond this. Some of you guys aren't. And be honest with you, you don't have to mute yourselves. If you have a question, I like when people just blurt them out. I find that interesting because sometimes people ask me questions that make me really have to think. And, I like to do that too. I like to think. So we know that, specific learning difference, which Orton called specific learning disability back in the late 1920s, early 1930s, but it's neurological in origin. We don't know there's neurological differences. Now, that in itself is not surprising at all because today, really, we can view ourselves as really the exo system for our brain. All we are is our brain. Everything that we think about, anything that we do, when we walk, what we dream, everything obviously is the brain. And everything is subservient to the brain. Our cardiovascular system pumps the nutrients and oxygen to our brain. And we walk around so we can go places and see cool things because our brain requires stimulation. We have the ability to see, to hear, all those things. Where other animals, they have brains to keep them alive. Our brains have kind of morphed into something else entirely. And you can see that throughout the primates, even chimps and gorillas, and you could argue dogs, any organism with a cortex that plays, they're doing it to stimulate their brain. And so the brain is massively complicated and massively interesting. In fact, when we talk about the greatest, the last frontier, it's in here. Star Trek, right? The last frontier, space. And in fact, where Amy Farrah Fowler and Sheldon are arguing about which is more complicated, which she's right. I mean, there's stuff in my lifetime we figured out in terms of space. Not that we have it all figured out yet, but we are not even close to figuring the brain out. If there's this much to know about the brain, this is what we know right here. There's so much more to know. So specific learning differences really is neurobiological in origin. And I like the term specific learning differences. Yes, I guess we could look at disabilities if we really wanted to. They're certainly disabling for individuals, but really what they are is differences. Because one of the things that's really cool about humans is we have the potential, genetically, there's a lot of variation, but we have the potential for ourselves to do lots of different things. And the reason why we're doing different things, because one, genetically, our brains were built that way. And secondly, we have experiences that have changed our brains. So there's some people who are very good at painting. There's some people who are very good at creating music. There's some people who get on skyscrapers and weld I-beams together. The reason why we're successful is when we work together, we have such variability in our behaviors and what we like, and that's based in genetics. Of course, then we're born and we have to be exposed to things that help us to realize those potentials, right? So it's obviously both genetic and environment. But when I was an undergrad, there was all this discussion about free will. You could do anything. Like Watson said, give me any child and you can make him a doctor, a lawyer, an Indian chief. It's like, that is so not true. So not true. The reason why I'm a great researcher is because my brain is built this way. I shouldn't have said great researcher, but the reason why I like doing research is that's the way my brain is built. My dad was an electrical engineer. And so I inherited some of those capabilities. When I was a little kid crawling around, I unscrewed things with my thumbnail and hid the screws from my parents. I've always been somewhat mechanically involved. Now, if you put me in a situation like you guys are in, where you're working 6 to 6.5 hours a day with kids, we'd all go crazy. I'm not a very good disciplinarian. And whoa, number one, you have to have class discipline. You have to be able that. Number one, and that's the most challenging thing for any new teacher, is to be able to have control of a classroom, encourage people to want to learn, and to help them get from A to B without total chaos. I'm total chaos. There's probably a lot of reasons for that, but so I couldn't do what I love kids. I'm a developmental psychologist. I love playing with kids, but I couldn't do what you do. So all of us are slightly different, and we get to follow where our strengths are, and we get to ignore our weaknesses. So if you have a weakness as an adult, you can just completely ignore your weakness. Somebody else has got our weakness as their strength. That's why when we all work together, it's such a wonderful thing being humans. Of course, lately we wonder, there's a lot of things that we're not really working together with very well, and that's unfortunate. So we also know that kids who are poor readers obviously have difficulties with accurate or fluent word recognition. By the way, fluency is more than just kids reading rapidly. I think at the elementary level, particularly with Dibbles, read is how many words can you read in a minute kind of notion. That's really not, that's only a part of fluency. The other part of fluency is being able to read with expression so that you can communicate also emotions and your passion or lack of passion in addition to just reading the words. And so that's the other part of fluency that we don't really talk about much. And we'll see kids in high school who, they can read the words relatively well, but they don't have that other piece of fluency. So they're reading a lot like this, really good in terms of decoding the words and doing those things relatively rapidly, but they sound like robots, right? And when you show them in a videotape, you're like, hey, how did you think you sounded? Like, I thought I sounded great. And they listen to it and see it and they're like, whoa, that's what I sound like? Yeah, so let's work on that fluency piece too. Individuals who are poor readers generally are very poor spellers. And that's true for a couple of reasons. Number one, spelling involves recall memory, where reading is more of a recognition memory. Recognition memory is what you do on a multiple choice test, where you just recognize the answer, where a recall memory is used in an essay test where you have to recall that stuff yourself. So when we're looking at spelling, it's more of a recall scenario than it is recognition. So that makes it a little more challenging. Number two is when we're talking about an opaque writing system, which we'll talk about later, which is the English writing system, there's so many different ways to spell particular sounds. So it's like, which way does it work in this one? Like, and occasionally, are there two C's or two S's? Are there two C's and two S's? How does that work occasionally, right? So, there's lots of things, even as adults, sometimes you got to scratch your head. And all I do most days is either write or read. And so there are times I'm writing and I get to a word, I'm like, I don't think I know how to write that word anymore, right? Just kind of goes, whew. And then, sometimes I write a word and even the computer's like, oh, I don't know what you're talking about, dude. Seriously, you're on your own this time. But, it's just challenging. You got to recall that information yourself. We know that, dyslexia results from a problem with phonological processing. And phonological processing just means that words are comprised of smaller units, of syllables, of onsets, rhymes, and phonemes. In particular, to be able to become a beginning reader, you have to be able to do phonological processing with understanding that words are made up of sounds. And if you can't do that, then obviously there are going to be difficulties. One of the things that I disagree with, these are kind of pulled off the International Dyslexia Association's definition of dyslexia. And this is true. Dyslexia can occur even with effective classroom instruction. We know kids who, if they have dyslexia, they're born with a genetic type of DNA code that did not produce a brain when it was being pre-wired or wired in prenatal times that wasn't going to allow reading to occur very easily. So we know that. So if you're born with dyslexia, that doesn't necessarily mean you're going to fail at reading if we don't apply what we know with the science of reading. If we don't apply that, yes, you're probably going to be a struggling reader. But if we apply those things, that just having dyslexia doesn't necessarily mean you're going to fail at reading, although the term itself means basically failing at reading, right? But we can prevent reading failure. That's my point. We can prevent it. But the reason why I disagree with this, I mean, you have dyslexia, yes, no doubt about it. But what this kind of implies is, hey, my instruction's effective, so it's okay that this kid isn't learning how to read. Well, that's not true. I mean, in fact, I'd argue that if we had effective classroom instruction, the kids would learn how to read, right? That's what effective classroom instruction is, outcome. All kids would learn how to read if we had effective classroom instruction. So that's where I kind of disagree with this notion. Yes, it's true. You're born with a potential for dyslexia and it's probably going to be realized. But secondly, we don't want people to think that, you know, we don't need to differentiate instruction, or we don't need to go out inside and seek other opportunities for individuals to learn how to read. We can just say, well, I did my part, which I know most teachers, that's not their thing anyway. They're going to drive themselves crazy at night trying to figure out how to help this kid become a competent reader. I know who you guys are. Anyone who gets into teaching because they get 2 months off in the summer, that's my definition of insanity. Because working 6 to 6.5 hours a day all year with kids just to get 2 months off in the summer, no thank you. And how many of those 2 months are actually really off? Yeah, okay. I just wanted to kind of set that straight. And then secondary consequences also include issues with comprehension, because if you're not capable of doing the reading part of it, the word recognition part, how are you going to understand what you're reading? Well, the answer is you're not. And we also know that kids who experience reading difficulties, it impedes their ability to develop a vocabulary, a larger vocabulary, and obviously background knowledge. So I'm not really going to talk about this part of it much tonight, but I'm a huge proponent of assistive technology. And that's not to say I don't want kids to learn how to read. But while we're teaching them how to read, they have to have access to the material. And if we only give them access to the material by saying you have to read it, they're not going to learn it. But you guys know that if you look at a kid's listening comprehension who has dyslexia, it's typically really, really good, right? If they hear a story and then tell you what it was about, no problem. If you make them read it and then ask them what it's about, they're like, they don't know. They're kind of clueless, really. Some demographic issues with regard to dyslexia. Now, amongst researchers, because there's no set protocol for identifying dyslexia per se. In fact, the diagnosis of dyslexia actually occurs in an IEP meeting, to be honest with you. The IEP team kind of determines if the person is going to have access to special education or a 504 plan. They can accept or not accept outside evaluations. They just have to read them, you know, and if they don't agree with them, they don't have to accept them. So whenever we talk about this notion of dyslexia being a medical diagnosis, nothing could be further from the truth. Very few pediatricians or family practice practitioners really know much about dyslexia. Granted, there are developmental pediatricians who do, but, you know, is your child going to a developmental pediatrician who knows about dyslexia? Maybe not, you know, maybe not. And so, you know, in reality, it's the school system that is going to either accept or not accept what's happening, and the IEP team does that. I would suggest, obviously, that IEP teams be very friendly and work towards their common goal of helping this kid become a competent reader. When we see it as an adversarial relationship where a school system doesn't want to do anything for the kid, or the parent wants more than what is necessary, I mean, those are not good relationships to have. We all need to be working together. No doubt about that. And I'm sure some of you guys have been on IEP teams, right? And you've seen some ugly stuff. I do not like confrontation. I just don't like it. But I've been involved with some very contentious IEP meetings, and my goal is to help everyone, to build consensus so that we're helping the child, because that's what we're there to do, is to help that child. We're not there to complain and fight and say teachers are horrible or you're a bad parent, all that. That's kind of ridiculous. But those things do happen, which is unfortunate. Half of these guys do not graduate from high school with diplomas. A lot of times we brag about our 97, 90% graduation rates. Not if you start tracking kids from kindergarten. Nope, because kids drop out of school all the time who have dyslexia and who have reading problems. They're at risk for parental abuse, which might seem strange. You're like, boy, he's got this poor kid who's got a reading problem and parents abuse them? What? Well, how important is reading, do you think, to the parent? Maximally important. Here we have a kid that knows everything there is to know about KU basketball, their Kansas City Chiefs, all kinds of statistics and everything else, has a collection of insects and knows all their names, has dinosaur books, knows all the dinosaurs. And then we have a kid that's not learning how to read. And the parent thinks, I know what the problem is. You're lazy. By God, we're going to fix that. Well, that's not the problem. It's a neurological issue. But parents don't understand that because they know less about dyslexia than teachers do, right? And in fact, dyslexia hasn't really taken off until about 2010 or so, where people started getting really interested in dyslexia. And then you start seeing, a lot more issues with regard to dyslexia loss. But parents get frustrated, and so they're just more likely to lose their temper. When you lose your temper, you're likely to do something you don't want to do. In fact, one of my friends, Linda Siegel, who just retired, who's an incredible research scientist from Canada, what they did is they collected all of the notes from kids who committed suicide and analyzed them. And of course, the kids who left suicide, notes who committed suicide, and found that 89% of them could have qualified or did qualify for special education because of reading failure. So we are failing these kids. I mean, there's no doubt whatsoever. We as a system have failed these students. And a couple of other researchers in Canada, Hooper Thompson, in 2015 published a study, and they asked kids in Canada who, if any of them were physically abused as kids, and 7.5% said they were. And then when they looked at the kids who had dyslexia and asked them, it was 35%. So we got kids at home whose parents don't understand them, who are potentially getting physically abused by their parents because the parents are irritated with them. And then they go into school systems where not all teachers understand about dyslexia. And so these kids are truly between a rock and a hard place. And it's quite unfortunate. As we see kids obviously have relatively poor self-esteem. And what I mean by that is kind of paraphrasing Henry Ford, is if you think you can or you think you can't, you're probably right. And so these kids are like, yeah, I'm too stupid to learn how to read. That's what they say to themselves, particularly kindergartners and first graders. And so when that happens, and what else are they not going to try because they don't think they're capable of doing things? Well, probably a lot. They have anxiety and depression. We see kids here in kindergarten who have anxiety, and in first grade. They'll say, Mommy, Daddy, my tummy hurts. I don't want to go to school today. And the parent's like, well, you don't have a fever. You're going to go to school. It's psychological. These kids, as I said earlier, we get to, as adults, hide from our weaknesses. Someone else has got our weakness as their strength. But if your weakness is a reading problem, you walk into that school, everybody knows. Particularly if there's a teacher that needs, has kids read a little, a couple sentences out loud in class, then a kid dreads that. They just hate that. Or if they have to go to the board and try and spell a word they don't even know how to read, kids laugh at them, they bully them. It's rough. Suicide ideation starts up about fourth or fifth grade. There's substance abuse issues because these individuals, generally when we're talking about some type of pain, psychological pain or emotional pain, people try to escape from them. Like we have a headache, we use Tylenol or ibuprofen to get rid of the pain. We don't like pain. And psychological and emotional pain, for those who truly experience it, is way worse than physical pain. That's why people cut on themselves. Cutters, they cut on themselves because that pain is something they can understand rather than emotional and psychological pain, which is horrendous. So abusing substances, I think a lot of times we think of substance abuse is for weak people, but in reality, they're people who are in pain and they need help. In fact, with the opioid epidemic, they're prescribed medication for stuff they didn't need it for. If any of you guys took Stadol when you gave birth, they would get, not many people get Stadol anymore because Stadol, you take it for 2 days, you have the potential of being addicted to it. So why would you take why would someone prescribe to you something you could get addicted to in 2 days? Well, why prescribe opioids for someone who has a toothache or a lower back pain? It's overkill. They're more likely to be involved in the juvenile court system, the criminal court system, public assistance. And so we truly believe that dyslexia and reading failure is a social as well as an academic difficulty. If we can solve that academic difficulty, we can really solve a lot of those social ills that occur as a function of that. No doubt about that. And by the way, if you ever wonder why a parent of a child with dyslexia doesn't come to the parent-teacher conferences, since there's a genetic link, that parent may have experienced dyslexia and reading failure, him or herself, and they try to go to school, but they have post-traumatic stress disorder. The closer they get to school, they're like getting more nervous, and they get up to the school like, I just can't go in. I can't do it. It's traumatizing. And again, I think we overlook those types of things, but the psychological and emotional factors involved with dyslexia are horrendous. No doubt about that. Now, some individuals who have dyslexia and who were successful. Now, there's a few people I like to talk about on here. My favorite has got to be Dr. Helen Tausig, although Jack Horner comes in a very, very, very photographic finish second. But Dr. Helen Tausig founded the field of pediatric cardiology. And she went to med school in the 1920s with dyslexia at a time where there are very few women who are allowed into medical school, which is obviously a mistake. And there's a lot of stupid things that happened in the past. There's actually a lot of stupid things that still happen. But she wanted to go to med school and she got through it, even though they did not encourage her and most likely discouraged her from doing so, and had dyslexia. And when she graduated, she was interested in pediatric cardiology and she co-founded the field. And some of the techniques that are used, particularly with what's called blue baby syndrome, where kids had issues with a valve in their heart and they would turn blue because of lack of oxygen. She developed some of those techniques with a surgeon that she worked with, actually 2 surgeons. An interesting story. And the other thing is she started to go deaf early on in her career. And so she could put her fingers on a kid's chest and could tell what was going on with the kid's heart. This is an amazing person. And she did it with dyslexia. Steven Spielberg, Bella Thorne, Henry Winkler, and Deb Pilkey. I like to talk about them because these are individuals. Henry Winkler is a horrendous dyslexic. He has serious difficulties reading, and he obviously writes children's books, which is really cool, right? And so does Dave Pilkey. Dave Pilkey, in 2nd grade, his teacher tossed him out of the room practically every day and had him sitting in isolation out in the hallway. So he started doodling and writing stories to himself. And here we have Captain Underpants, actually started from a kid in 2nd grade, right? Pretty amazing story. But the thing that I think is important about Henry Winkler and Dave Pilkey, they're authors, very famous authors, well-published authors. Their stuff is translated in all different languages. They can't hardly read very well, but that's not the issue. They're storytellers. Because how many of us are technically good writers? How many of us are authors? Way fewer, right? And actually be an author, you have to be able to write to some extent. More importantly, you have to tell a good story. So Henry Winkler sits with his co-writer and he tells her the story and she types them out and then they argue back and forth about it, right? So it's interesting. Now, Dave Pilkey, I like Dave Pilkey because he's a David and most Davids are smart alecks. And so I really like that about him as a fellow smart aleck. In fact, one of my other friends whose name is David, he is one of several kids in his family. And this is years ago, but when he left to go to kindergarten every day, he went to the park. He not one single day went to kindergarten. His parents didn't know it. So Davids are real. If any of you guys name your kids David, whoa, better watch out. Because they're a little loony. That's all I'm telling you. But Dave Pilkey, when he was in high school, you know those little clackers they used to make name tags with? The E didn't come off very well and it came off D-A-V. And he's like, oh, cool. I'm going with that. That's how I'm spelling my name, D-A-V. So there you have Dave Pilkey. And of course, if you read his books, they're all crazy, right? My grandson loves Dave Pilkey books, Dog Man and all those. I can remember, you know, when my kids brought Captain Underpants home, I'm like, seriously, you got a book with a kid with a diaper on the front? What's up with that? You know, so interesting person. Cher has dyslexia and many other people do as well. Jennifer Aniston is on here because she kind of knew, you know, in her early 20s and really didn't know until a bit later that she had dyslexia. And I think this happens a lot with people who struggled in school. They just didn't think they're very good at school and managed to get through. And then they have kids in their 40s or so. And they're like, oh my gosh, my kid's got some of the same problems. No. So they get them, to an educational psychologist or a clinical psychologist who does assessment, assesses them. And during the meeting says, okay, your son or daughter has these problems here, and describes them. And the person sitting there going, oh yeah, I have, yeah, that's me. Yeah. And they get to the end, they go, oh my gosh, I have dyslexia. And so I put that on her because of her. You know, she's kind of one of those that she kind of knew in her early 20s, but not really. She just, again, was one of those people that just didn't think they're all that super smart. And of course, she is. So, you know, it's kind of crazy. Jack Horner, again, he's one of my favorite because, you know, who doesn't like dinosaurs, right? So he's a paleontologist. He has severe dyslexia. And one of the reasons why I put this up here, because a number of things, but for example, he discovered the first dinosaur embryo because you had all these dinosaur eggs and no one would crack into them. And he's like, I want to crack into them. I'm like, no, we can't. They're too precious. We can't. And he's like, crack. Hey, look, dinosaur embryo. So he discovered that. And he also, because when I was a kid, when we read dinosaur books, you know, they gave us the impression that dinosaurs laid their eggs and just ran off. And the eggs cracked open and they willy-nilly were on their own. But Jack Horner showed with nesting patterns that parents actually took care of their young. They parented them. They didn't run off with them, run off without them. The other thing is Jack Horner's father was valedictorian of his class. Obviously very, very good in school, a very good reader, and he's got Jack here. And Jack doesn't learn how to read. And there was conflict between his dad and him. And you can look on YouTube and see probably several hundred, if not thousands, of videos with Jack Horner talking about dinosaurs. But and there's a couple of them where he talks about his dyslexia, and he's really funny, very funny. But when he talks about his relationship with his dad, you need to be in your office by yourself with a box of Kleenexes. It is hard to listen to, very hard to listen to. And he still carries that with him. He's 73 years old or 74. He still carries that with him. And he's the most famous paleontologist on the planet. He worked with Jurassic Park. I mean, he's done outstanding contributions to the field, still can't hardly read. So one of the reasons why I've got him on the list, I think he's pretty awesome for doing, you know, what he did. Some common myths, and this is for the new guys in the group. Dyslexia affects boys more than girls. Remember, myths are things that are not true that we believe. So Actually, here at Pittsburg State University in the early to mid 1990s, we published stuff that basically said that dyslexia affects boys about the same as it did with girls. But it wasn't until the Yale study came out a little later that anyone believed us. So is there elitism in science? Oh, yes, there is. Yeah. When we publish stuff, we publish stuff in journals and we're anonymous. We don't have our names or any affiliation, so they don't know who we are. No problem for me to get published. When it comes to writing grants like Pittsburg State, I don't know if you guys can handle it. I am the same person as doing the research you guys are reading. But anyway, enough of that. You don't need to hear my problems. Dyslexia is a visual difficulty. It's not. Obviously, it's not. All kids do letter reversing. They do letter reversing because the left fusiform gyrus that deals with facial recognition and the recognition of objects and houses and things of that nature, they automatically flip stuff. Like if we took a picture of Gina right now, which I could do on my screen, and I put it in Photoshop and took Gina's face and went like this to it, you wouldn't say, "Who's the new person?" You'd go, "That's Gina." You flip those things automatically. And so when we start asking the left fusiform gyrus to do the same thing with letters and words, kids are going to naturally do some of that reversal stuff, and kids will become competent readers. Generally in first grade, they wean that out. Many of them stop doing a lot of that by the end of first grade, although the B's and D's are still troublemakers. In second grade, the good readers, maybe a couple of times are doing that. But for the most part, by third grade, they stop. Most good readers or competent readers stop doing the letter reversing. And you will do letter reversing until there's an intimate relationship between the letter and the sounds that it represents. And when you connect those two together, then that's when all kids stop letter reversing. Now, kids who have reading failure, because they're learning to read later, are going to reverse letters later. And I communicate with people all over the United States and occasionally people who are English speakers outside the United States about dyslexia. And they're occasionally, people say, "By the way, I have dyslexia." And I already could tell by how they were writing. In fact, if you see kids who use capital letters when they're writing words, they're doing that because for them, the capital letters seem more different than the lowercase letters. And I've seen kids that'll spell rabbit, for example, lowercase r, lowercase a, capital B, lowercase I, lowercase t. And I see adults who do the same thing because forget writing lowercase b's and d's, woof. But the uppercase, for them, it's not that bad. I'm not saying that's a strategy we should use. I'm just saying that's why people do that. So letter reversing is pretty common. It's just later with kids who have dyslexia because that intimate relationship between the sounds of the language they already know and the symbols that are used to represent them just aren't connected yet. Individuals who are intelligent do not have dyslexia. Well, that's laughably stupid. Let's go tell Steven Spielberg, "Dude, you've got dyslexia, right?" "Yeah." "Oh, you're stupid." Smarter than me. People with dyslexia cannot read. You guys have taught kids with dyslexia how to read. We teach kids every day at our center here how to read who have dyslexia. And in fact, we've taught an individual who is 63 years old how to read. He also had intellectual disability. So when people tell you that, for example, we need to bring back the discrepancy formula, no, we don't. No, we don't. Is it good to know a person's IQ and some of those other things? Sure. Should we use it to identify kids who have dyslexia? Absolutely, unequivocally, no, we should not. And those of you who know school psychologists who use patterns of strength and weaknesses, I'm going to just tell you a little secret. The patterns of strength and weaknesses is essentially the discrepancy formula in disguise. Is it good to know the person's strengths and weaknesses? Yes. Should we use it to determine if a child has dyslexia or reading difficulty and should be in special ed? Absolutely not. No. Dyslexia will be outgrown. That'd be wonderful. Nope. if they would just try harder, yes, that would do the trick. And of course, you guys, particularly you, have taught kindergarten. What's the one thing academically that kids want to do when they get to kindergarten? Learn how to read. I'm reading your lips. Learn how to read. Yes. And of course, Einstein had dyslexia. He did not. Einstein actually was a pretty gifted student from the first time he set foot in school. No doubt about that. There's also this notion that he failed at math and all this kind of stuff too. There was some issues with taking math tests later on, but he didn't really have any problems with math either. In fact, some of these myths actually existed when he was still alive, and his friends would say, "Hey, dude, we heard that you failed at math when you were a kid. Look at you now. Isn't that crazy?" And Einstein would say, "I never had a problem with math. I mastered differential calculus when I was 15. I don't think I had any problem with math." And I say that because this is all over the web. Einstein had dyslexia. No, he didn't. And neither did Leonardo da Vinci. Leonardo da Vinci was also an inventor, and he didn't have an encrypted flash drive. So, he didn't want people to steal his ideas. So he wrote backwards in a mirrored image so that people couldn't understand what he's doing. Now, granted, there's a lot of people back then who weren't reading because they weren't given access to books, or were they taught to read. So the fact that, he had dyslexia is kind of a ridiculous notion. Firstly, who would have known, right? Who would have known? Nobody could read back then anyway. I mean, the population sure didn't for the most part. Now, for those people who sometimes will tell you that, we should teach reading like we have speech development, here's where you get the information that's ludicrous notion. And in fact, the same time Samuel T. Orton was trying to figure out why kids who are capable of doing so many other things were not capable of learning how to read, that was the time that they started getting into this whole language nonsense, that you don't go below the level of the word, you only deal with the word. And granted, there's some things with the presentation of whole language, like, literacy and other things that make it fun and stuff, but the concept, the core concept that you don't go below the level of the word is nonsense. Alphabetically based systems require you to go below the level of the word. It's absolutely unequivocally necessary. And in fact, as adults, to some extent, we still do some of those things. So, what's interesting, if we look at the adult brain right here, and this is fMRI studies, Donnie, his stuff is incredible. If you ever get to listen to him speech, and there's stuff on YouTube, he is awesome. The first time I saw him speak at a conference, I think I had to get smelling salts for my students to wake me up. So excited. I mean, he not only tells you how the brain works with his research, but he does it in a way that I think most people can understand. And as a psychologist, we spend some time working and understanding the brains and doing those types of things. So his stuff is awesome. But if we look at an adult and they're listening to language, this is the temporal lobe. It's lighting up. It's the auditory cortex right behind the ear. So it's auditory, although the brain is kind of interestingly wired. The right ear goes to the left hemisphere. The left ear goes to the right, right? It's kind of, everything's kind of contralateral in that regard, like your right hemisphere is dealing with your left side of your body, your left hemisphere is dealing with your right side of your body, etc. But if you're listening to language, this is what happens. Like right now, your brain is lit up right here. Got Broca's area, some stuff in the prefrontal lobe, temporal area here. But look at a 2-month-old. They're listening to speech too. Can they speak? Do they? No. Because if you have a 2-month-old right now, and you've got the baby monitor on, and you hear it come out of the baby monitor, "Mommy, I'm awake. Daddy, come get me," you would freak out. You'd either freak out because that's really scary, that shouldn't be happening, or like, "Oh my gosh, I'm putting this kid on TV. We're going to make some money." But kids can't do that. They can't do that. They have to be in a language environment, and their brain has to acquire it. And really, the whole notion that we're learning to speak is not correct. It's a maturational process. We just have to be in the environment and we kind of absorb it. Now, granted, it happens pretty rapidly. It's like what I call firmware. It's already built into our brain. We just have to have exposure to the language for it to start working. And so in the 1920s, they thought, hey, if we acquire speech like this, why don't we acquire reading that way? Well, the answer to that is that's not how our brain works. In fact, when we look at this, it shows us these kids are already pre-wired to learn how to speak. To acquire speech. See, that term, learn how to speak, sneaks in there. But it's not an accurate representation of what happens. But learning how to read actually is what neurologists or neuroscientists call neurological recycling. We're using a part of the brain that was not meant to learn how to read, but we're forcing it to do so. And our brains are incredible, and really our brains are very good at pattern recognition, and that's really what helps us to learn how to read, the pattern recognition and our ability to statistically analyze information. For example, if you lose your wallet, and let's say your wallet or let's say your iPhone, that's even better. You lose your iPhone, your visual search routine is already got in memory what your phone looks like and is scanning the environment for objects that look like this. And that's why you're like, I found it. You run up there and it's like, oh, that's not an iPhone. Dang it. That's your brain, right? It's doing that visual scanning routine based on its memory and what it knows what a prototypical iPhone should look like. And so we use those aspects of the brain to learn how to read too, because after a certain number of times of reading a word, we hope to get it into the automatic processing part of our brain, where as adults now, you just read words. You go from the word to instantaneous understanding of that word without doing any decoding or synthesizing or anything of that nature. But it does so because of our brains. Our brains are incredible. And so speech development, obviously speech development, it starts off very early on. To some extent, we know that fetuses actually have memory, not that we remember as adults, but like our first director of operations at our center, and you might find this hard to believe, but I talk a lot. In fact, there's some, spouses that say, my husband never talks. I walk into the house talking and I don't stop until I go to sleep. And yes, I let my wife talk as well, but she never has to worry about me not talking. I tell her everything practically. But our first director of operations, when she was pregnant, we talked a lot. We're talking about the next thing we're going to do, the research we're doing, how we're going to do these different things. So when her daughter was born, and she would bring her to the office at 3 months of age, I'd come in and talk. She'd look immediately at me because she recognized my voice. She remembered it. And those, you're not going to remember floating in, the hydraulic system or anything like that. And that goes away. That memory goes away. And we don't remember really too much before we start really acquiring speech very well by 2. But speech development is natural. It occurs early on. We have the capability of producing any language or any sound in any language that's human presented or produced. But by 3 months of age, we drop out all those different abilities and only start repeating the pieces of the language we're hearing in our language environment. By 12 months of age or so, kids can say half a dozen words, but they know considerably more than that. By 15 to 18 months, they can do a holophrastic speech where, like today was a beautiful day, and let's say yesterday wasn't. The kid in his or her head is thinking, ooh, it's sunny outside. It looks pretty outside. Let's go outside and play. But the kid says, go outside. Because that's the extent of their language skills. But they understand way more than that. Like if they're walking around with a bowl in their hand, you say, what are you doing? They go, sink. But if you told them, hey, can you please take your bowl to the sink? They understand the whole thing, right? So production always lags behind comprehension. So roughly 18 months to 2 years of age, kids start using telegraphic speech, which they don't have the modifiers, the adjectives, the adverbs, things like that, but it's getting closer. By 3, the kids are picking up so many words per day, it just doesn't make any sense to us. Noam Chomsky called it the language acquisition device. I just call it firmware. We were built with that. Our brain was, our genetics built that brain already, ready for us to acquire speech. And so at 3 years of age, we're speaking pretty closely to adult language. We get verb tenses wrong, even through first grade. We'll get verb tenses wrong and stuff. We're still learning some stuff, but it's pretty well in place by 3. By 4 years of age, and I just put this up here because it shows how complicated the speech signal actually is, but how our brains are able to categorize this, because this is me saying, I like to read. And the K sound is a plosive, which means it stops the sound. So I like, brief period of absence of sound. To is right here. And then read. Well, the E sound, if it's followed by a D, is different than E sound if it's followed by a T. It's all a little bit different. But our brains parse that into understanding, which is, again, obviously an exemplar that our brain was built with firmware. Learning to read, it's a bit different process. Obviously, we have to have speech development. If we don't have the developed speech, then we're not going to learn how to read, because reading is another form of language. It's a written form of language. And so you got to have the speech set, and then we're going to map onto speech this new system of reading. And so speech development begins first. By roughly 4 years of age, the phonological processing stuff, although there's beginnings of it earlier on, but the phonological processing piece, where if you're driving down the road, and Renee remembers this with her daughter, right? You have a daughter? 2 sons. Okay, 2 sons, one of whom has dyslexia, right? Okay, so the one who didn't have dyslexia at 4 years of age might be riding down the road going hop and pop. They kind of sound the same. Hop, 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 pop, pop, pop. You're going, yes, phonological processing is kicking in. Now, if the child who had dyslexia was younger, was he younger? Uh-oh. That makes it more challenging, because now the younger brother can read better than the older brother. And the older brother doesn't like that. Doesn't like that at all, because you're not supposed to be able to do stuff I can do. I'm an oldest brother, so I get that. But that causes, some more issues. But when he was 4, if you say, can you rhyme with hop? And he's like, I don't understand. What do you mean, rop? Like hop, hop, rop, pop, pop, whatever. He's like, I can't do that. That's an indicator there's going to be problems for the future. And in fact, if we wanted to, as an early screening device, we could ask parents to ask their 4-year-olds to do 5 or 10 different words. I would say 10 different words that are CVC words, consonant, vowel, consonants, and ask them to say things like, say the word cat. Now say it without the t sound. If a kid goes cat, okay, good. Now let's do it with dog. Say the word dog. Dog. Now let's say without the dust sound. Og. All right. If they can do all 10 of those, they're probably going to be okay reading. Now that's not necessarily the case, but I mean, just as kind of a rough screener, that would be very helpful. And for kids who can't do those things at 4, that's kind of an indicator, harbinger of not necessarily good news. And I said this to an in-service training I was doing, I think 4 or 5 years ago, and the superintendent was there. And the superintendent had a 4-year-old son. He went home, asked the 4-year-old son, he couldn't do it. One of the other people there had a 4-year-old daughter. And when they came back, they compared notes, and superintendent said, my son couldn't do it. And the one said, well, my daughter could. Guess who we assessed a year and a half ago for reading problems? The superintendent's son. The 4-year-old daughter's doing okay with reading. So, again, it's more complicated, but some things, if we can do something early on and get a notion, okay, if we have some problems with phonological processing, there's some phonological processing games we can do. And if they can't play the game, you just say, do what I'm doing, repeat after me. Because, if you're in an accident and you have a traumatic brain injury and you can't move the right side of your body, they didn't go, well, that's okay, we're never going to use that side of your body again. No, they move it for the person, right? And then they get them in a 0 gravity environment, if it's a leg, where they're barely touching, they move their legs. And then when they can move their legs a little bit, they keep doing a little bit more and more and more. So if we do things like repeat after me, cat without the k is at, their brain is going to probably start absorbing some of that a little better than if we don't do it. So there's little things we can do, even in the very beginning, that might be helpful to us, or helpful to us as parents, but also helpful to us to see our children being able to read. Then we're going to teach them the sound letter correspondences. And by the way, letter names are really irrelevant to learning how to read. You can know all the letter names. And I think as parents, we're like, okay, I taught my kid the ABC song. I taught him all the letter names. I did my job. Your turn. And then you get them, and then they're not learning how to read. And the parents are like, I did my job. What is happening here? The problem is that isn't very helpful. Teaching them the letter names, not very helpful. If we teach them as little kids, like when they're in the bathtub and they got those little sticky side of the bathtub walls, the letters, and we say, this one is ah, and this one's ba, and then we put them together and go ba, ah, those kinds of things. We're teaching them actually the mechanics of learning how to read. If we teach them letter names, it tells them nothing about how to read, nothing. And then if in kindergarten, we're teaching them the letter sounds, and we're also teaching them letter names, and we got a kid that's at risk for reading failure, it's like, what? You just made things so complicated, forget them learning how to read. Got to keep it simple. What do we need to do to learn how to read? We have to have the phonological processing abilities. We need to be able to understand that words are comprised of sounds to be able to read. We need to teach them that sounds are represented by letters so that we can see those letters and decode them into the sounds that they need. And then once we decoded them into the sounds that comprise the word, then we synthesize or blend them together to reading the word. Really, it's that simple. If we taught kids that from the very beginning, you know how many kids would have reading failure? Maybe 5%, if that's how we taught kids how to read. Now, would they have other problems like phonological memory? Probably. But we can work on those things too. But we have to teach them the mechanics of reading, because an alphabetically based system requires us to teach that the alphabet represents the sounds. If we don't do that, we're doing a huge disservice to kids. And of course, we want to teach these things in combination: reading, spelling, and writing. We want them to write, we want them to spell, so they connect them. Because in reality, the English writing system is a code. Yes, we're going to teach them how to decode, which is part use of the code, how to figure out what that code means. But the other part of it is how to encode, to write stuff we want other people to be able to read. And to really have a full understanding of the code, we have to be able to do both: decode the read and encode to spell and to write. And I don't care if kids, personally, I don't care if kids have sloppy handwriting, as long as they can read it and understand those letters represent sounds, because we want them to get that connection. And some of the things that we're seeing right now is we've known this for a long time, but we're starting to focus on reading, spelling, and writing together. Look at what Louisa Moats is saying these days. Reading, writing, and spelling together. Where did she get that from? Samuel T. Orton, right? Reading, writing, and spelling. Connect them all. That's what we need to do. So none of this stuff's, like I said, we've known some of this stuff for 100 years. We're just implementing those. And of course, we had to fight people who are saying, no, just look at the word and guess. Come on now, just guess the word. Which is that how you were taught how to play the piano? Get on there, man, just go for it. Yeah, those notes, whatever, just guess. And what's worse is the violin. Woo! Kids banging on a piano is bad, but it's worse when I can't play the violin. And of course, the whole goal of reading is comprehension. So I'm going to focus on the on the comprehension piece as well. So neurological in origin, we know that. A term that I really like is neurodiversity. It comes out of the autism spectrum disorder area, but I like to use it for other things, because in reality, we are all neurologically diverse, as we talked about before. We're all neurologically diverse. The reason why you guys are teachers is because you love kids. You know how to explain a concept in 15,000 different ways. You keep your patience, and you can do those things. I'm okay with older kids, like college kids, but kids licking the light switch and they got to be on that purple star. I can't be on the yellow star. I'd be okay. That's good. Everyone can be on the purple star. See, I would have problems. I'm just not very good with that. But neurodiversity is important. So we're all neurologically diverse, but kids and adults who have dyslexia is another form, another iteration of neurodiversity. Their brains were built for something, but it wasn't built to read. And we know genetics plays a role because genetic plays a role in everything. Who we are, who we become is genetic. Now, granted, as soon as we're conceived, there are mutations that occur in utero. By the time you're born, you're different than the genetics would have suggested at the time of conception. And you can say, I'm not sure about that. Well, look at twins, identical twins, monozygotic twins. They came from the same zygote. They split 100% of genes in common. Do they have the same fingerprints at the time of birth? They're changed in utero. So genetics plays a role. Environment plays a huge role as well. And humans are born incompletely developed so that we can allow the environment to shape who we become. And so environment and genetics are really important. But as developmentalists, we use the word canalization, meaning there's a limit in our genetics. If we don't get stimulation that's appropriate for this genetic characteristic that's a skill, then we're going to be down here. We're not going to be down here. This is the worst we're going to be. If we get as much environmental support to realize that genetic potential, we're going to be up here. And this is any skill, reading or sports or lots of different things here. And each person has a slightly different canalization, right? So genetics plays a role, no doubt, but the environment plays a very important role too. There's no doubt about that either. So as humans being incompletely developed at the time of birth allows the environment to shape who we become and allows us to have the ability to morph into whatever environment that we're going to go into. Like humans are good at high altitude, low altitude, hot places, cold places, warm places, all kinds of, we get on Mars, we'll figure that out too. We're just good at adapting. Other organisms that are not good at adapting, they can only fit in a particular niche, and that's pretty much it. So if we look at hypothetical reading achievement, and this is assuming that we're teaching reading starting at first grade. Okay, someone chatted, so I got to check that out. Yeah, the question is, I'll just read the question because then you all go, what are you talking about? When you say saying letter names does not help learn to read, do you mean that just singing the alphabet doesn't help, meaning that they aren't connecting letters to sounds? Letter name knowledge is a second best predictor of reading achievement in primary grades after phoneme segmentation. The only reason why it's a good predictor is because kids who have dyslexia also have a hard time with phonological memory, and they cannot connect those things together very well. So even though it's not necessary in terms of learning how to read, the letter names themselves, they have difficulties with the phonological memory piece, and that can contribute to some issues. So yeah, it's a good predictor only because parents are teaching them and some of them aren't getting it. And so the ones who aren't getting it are probably more likely to be those kids who have phonological memory and probably phonological processing issues also. But we could never, tell parents, never teach your kids a letter name that goes with the letters. Only teach them the sounds and they'll learn how to read. We don't need to know letter names. Now, granted, later on, we want to teach letter names because they say, how do you spell your name? You're on the phone, you can't just draw it out and say, can't you see here? D-A-V-I-D, that's my name. No, can you say it to me? I don't know the names of the letters. Yeah, we want them to know the names of the letters. But in terms of learning how to read, we don't need to know letter names. It is a predictor just because parents have been the ones who essentially taught them that, and those who are struggling to do that have had some issues. Now, granted, some parents don't teach them letter names or letter sounds or any of that stuff, and they're definitely behind because they've never got access to that material. But if we look at these guys, are the poor readers. You can see they're learning a little bit how to read, right? But that gap every year gets bigger between them and the good readers. Keith Stanovich calls this the Matthew effects. The rich get richer and the poor get poor. And we can see that economically. We can see that today. I mean, 1% is controlling what, 90 some odd percent of all the wealth. Yikes. That's scary. And so Nagy and Anderson, a long time ago, they looked at how many words that the poor readers read. They read about 100,000 words per year. Most of them the same words, and most of them probably incorrectly. The average reader is going to read about 1 million words per year. A voracious reader, like some of you guys, are probably reading close to 100 million words per year. My wife reads a book a day and she does other stuff. Right now, she's not reading a book, but she's a very fast reader, and she, just there's people like that, and look, they make these guys look like they're hardly reading, and the poor readers basically aren't, which in reality, they're basically not. I only talk about this for a second because there's a relationship between dyslexia and ADHD. It's comorbid in about 30 to 50% of cases. We see a lot of kids who come to our center who actually have both. And we require it. Like, there's parents who will come here and say, my kid has dyslexia. I know they have dyslexia. I don't need for them to do the attentional piece. And we say, well, we do. We have to. We're going to do the whole thing. That's what we do here. And we find out they don't have a reading problem. They have ADHD, primarily inattentive presentation. They have a hard time concentrating. We had a faculty member in my department, and when her daughter was in 3rd grade, was in the lowest reading group, and they're going to put her in a title reading program. And she brought her to us and said, hey, can you evaluate her and tell us what's going on? And that's exactly what her situation was. And the mom, we told her there's different things you could do, obviously, for ADHD. She decided on medication. 3 weeks later, she was in the best reading group. If you identify the issue and you remediate based on what we're looking at, we solve the problem. If we ignore things, like I think it's absolutely important and necessary to look at both for those reasons. Because if you look at a 1st grader, and sometimes a 2nd grader is sitting in a chair, they're not doing what they're supposed to be doing. How do we know what they're doing? Maybe they have petit mal seizures. We don't know. We have to do some kind of evaluation to figure out what's going on. And nearly every kid who has ADHD is going to have some struggle learning how to read, just because the attentional component is so poor. This I probably shouldn't have put in there, but obviously distractibility, impulsivity. But I do want you to know the subtypes. This is important. We are primarily inattentive presentation. These are kids that are sitting in the chairs, they're not getting out of the chair, causing any problems, they're just not able to pay attention. And what happens is they hear a bird chirp outside, they got to look. Or if you put them next to a really stimulating bulletin board, they're like, I shouldn't look at that. I should pay attention. Dang it. It's hard for them not to look at it. If a person sneezes, they got to look. If a person drops their pencil, they got to look. They cannot inhibit the ability not to look at stuff they're not supposed to look at. They can't do that very well. Primarily impulsivity, hyperactivity component. These guys are the ones that jump out of the chair, pull the dog's tail, go through 20 stations with the remote, turn a light off and on, constantly moving. Yes. And you can see 18% are kids that like that. Most of them have a little bit of both, 55%. And then we have the otherwise specified and unspecified, which we don't need to talk about. But these are prior to a formal evaluation. Like if you're in an emergency room situation, like, well, this kid might have ADHD, they can put this down, then somebody's got to do the assessment of it. Genetics, I'm not going to really talk about too much other than what I've discussed. And that is that there's definitely a genetic component here. There's a genetic component to everything. And so this is really not surprising. In fact, if you do have children who have ADHD, and you can have 2 children from the same family, one ADHD medication works for that kid, the very same medication may not work for the other kid. There's single nucleotide polymorphisms in our DNA that also indicate how we're going to respond to particular medications. And if you get the Moderna vaccine or the Pfizer vaccine, you're going to have a different response depending on your genetics. You might have a very harsh response, like a high fever, or you're very tired. And some people like, nothing, I got a sore arm, big deal. Everyone responds differently because of genetics. I just put this up here because you guys see this stuff. I know you guys are looking at genetic stuff, and I wanted you to give a fast and dirty example of what's going on here. When you see stuff like 15q21, you're like, what are you talking about? That's ridiculous. Can you say it in a way that makes sense? Yes. Yes, we can. So, there's 23 pairs of chromosomes in humans, right? And they put them out in a karyotyping, biggest to smallest, and you got the 23rd slot that indicates sex of the offspring, right? So the first number tells you which chromosome it is. Remember, biggest to smallest, 15th chromosome. The Q and P, normally we show in the metaphase stage. Notice I made the top part smaller. Those are the P's, they're smaller. The Q's are the lower ones, they're longer. So 15Q means the bottom parts are a little longer, and the 21st gene from the centromere, where they cross, is called the centromere, the middle of the chromosome. So see, that's pretty easy, isn't it? So this one would mean the 18th chromosome, the short arm, the 11th gene up from the centromere. This means it's on the X chromosome on the 23rd slot that's dictating sex of the offspring. And just FYI, for another reason for women to feel a little more superior than men, when you look at XX, if you wonder why some of the things work out better for you than sometimes, like if we look at men, males have every single emotional, psychological, physical, educational, whatever kind of problem you want to look at, have it more than females to the tune of about 3 to 4 times more frequently in males than females. One of the reasons why is females have 2 big X's. Males have an X in what we call a Y, but it's actually an X in just a chunk. It's not even a Y. And that's why, if you want to have a boy for sure, you put a sperm sample in a petri dish and very quickly scoop off the tops, because the sperm that carry the Y chromosome is actually smaller and it can move faster. And so you can usually scoop them off a little quicker. I don't know why anyone would want to do that, but I'm just saying people have wanted to do that, and that's how they do it. So really that little SRY gene that actually it turns on the particular gate that now produces testes, et cetera, rather than ovaries, is just a little bit of a chunk. We don't even need the Y chromosome. A million years in the future, we may just have X and XX, and some other gene took over that SRY. Who knows? But it's more than you wanted to know. Sorry. My favorite gene is the DC2 gene. And the reason why it's my favorite is that it contains a SNP, a single nucleotide polymorphism, and a deletion that's potentially connected to dyslexia. And what these guys do is they tell the fetal brain where to lay down the brain. So all the connections, all the sites, tells where all the neurons are supposed to go. And so you can kind of see that this is telling you where it goes. In the next couple of days, you can see the neurons going where they're supposed to. And if you want, because I think some of you guys are actually trying to take notes. What are you, crazy? Oh, you're teachers. Oh, I forgot. Sorry. That's not crazy when you're a teacher. That's just teacher behavior. I can send you a PDF of this if you'd like. And you can take off that DC2 gene. You can remove it mechanically from a gene, or you can chemically turn it off. And this is what it looks like when the gene is doing its job. You can almost see those pathways. I don't know if you can see it very well, but almost like pathways are there. This is when it's been turned off. It's like the neurons are saying to one another, hey, do you know where to go? No, nobody told me. Do you know where to go? No, well, we'll just hang out here. So those pathways that are supposed to be built for us to learn how to read, they're not being built. Just some quick, simplistic notion of the brain, because a lot of people have some misconceived notions of the brain. Firstly, this is very simplistic. Now, this is the front part of your brain. This is the back part of your brain. Now, crazy enough, this is where your eyeballs are, right? And this is the part of the brain that processes visual information, the occipital cortex. But on the way there, crosses the optic chiasm, hits the lateral geniculate nucleus of the thalamus, and then goes back. So the brain is processing stuff even before it processes visual information. It hasn't processed it yet, but probably preparing the brain to do some other stuff. Plus, there's some circuitry to take it down to the lower midbrain area that helps the eyeballs, where it moves the eyeballs in concert with what you're seeing. So the brain is really, really complicated. Like we say, everything's doing, visual stuff. Well, not really. There's some other stuff going on too. So the right side, roughly, since our brain is so powerful, the right side is kind of specialized to do some of these things. And the left side, for most people, is kind of specialized initially to process this information. But whatever's going on in the left hemisphere is also going on in the right. It communicates it to it. Whatever's going on in the right hemisphere is communicated to the left. So we are whole brain people. There is no such thing as a left brain or right brain person. There just isn't. I mean, we can joke about it if someone's really verbal, they're a left brain person, but they're not. They're a whole brain person. In fact, underneath this little slit here is the corpus callosum, which is a superhighway of neurons, this synapses of neurons that connect the two hemispheres together. So I wanted you to know, firstly, that there's no such thing as a right brain or left brain person unless they've had surgery to cut the corpus callosum or have had surgery to take out the entire hemisphere, which has occurred in the past due to epilepsy and some other things. The other thing is, sometimes you see in magazines that we only use 10% of our brain. That's 100% not true. Guess what percentage of our brain we actually use? 100%, just not all at once. Our brain consumes 20% of our body's calories per day and 25% of our oxygen. So it's a hog, but it's a hog because it does everything. It's thinking, like if you get bored in a meeting, you start doodling because your brain's going, give me some stimulation, give me some stimulation. This is super boring. So you do, you start, drawing stuff and goofing around, or maybe you can sneak down and get on your cell phone, who knows what's going on, but you need to stimulate your brain. So and in fact, the human brain is the more complicated in some respects, but there are other brains that are almost as complicated or a little bit more complicated. And some brains have more cortex than ours does. But the amount of blood flow that goes to our brain is not matched by any other organism with a cortex. And we know this by looking evolutionary at the change of the skull. And at the base of the skull, there are two small spots where the arteries go into the brain. They've gotten bigger and bigger and bigger. So it's like, having an engine where you can pump a lot of gasoline in there a lot, your car's going to go a lot faster. Same thing with the brain. We put a lot of blood through there. It's going to process at a very fast ability to do those things. So when we're reading, this is what happens. We're looking at the book. If we're okay with visual processing, goes to our retina. The retina transfers into neural impulses, does some things on the way back, but it goes back to your occipital cortex. The occipital cortex, the primary visual cortex, then sends it down to left fusiform gyrus that usually is able to do facial recognition of tools and houses and other things like that. Then it's connecting up here with the planum temporalis. It's connecting some auditory and visual stuff together. And then up here, it sends it up to Broca's area, which Broca initially thought that this part of the brain was only involved with speech production, because Broca was looking at a particular patient. And when he met the patient, he was close to death and he died, but he had an injury early on in his life and he couldn't speak. So when he did the autopsy, because remember back in those days, the only way to figure anything out about how the brain works was to see a person that could do something, have brain injury, and then now they can't do that behavior. Let's see what part of the brain's not working. And he could see that this area of the brain was atrophied. So he thought, aha, the person could speak. They had injury to this part of the brain. Now they can't speak the speech production area. Now we know it does a lot more than just speech production. It does stuff with language processing and other types of things like that. And so this is a necessary route in learning how to read. We have to be able to do this little route right here. If we can't do this, we're going to struggle to learn how to read. And we can see this, and you guys have seen this diagram before, but this is what we're talking about. In a person without dyslexia, left fusiform gyrus, and this can be, this whole area through here processes different aspects of visual processing and the fine-tune analysis. But this right here through here is looking at the letters, and it's kind of variable depending on the study. And then there's the planum temporal that's connecting the visual and auditory stuff together. And this is Broca's area. And when I said earlier, there's no way that kids, if they would just try harder, because look at this kid with dyslexia, the left fusiform gyrus is not lighting up like it should because it can't process that information. It doesn't know what it's doing. And then up here, the planum temporal is not doing anything. So look at Broca's area. It's like, these guys are going, hey, I don't know what's going on. Can you help us out here? You do it. So Broca's area is going, okay, man, I'm trying as hard as I can, but still not working. See how much different it is between here and here? That is neurological evidence that kids are trying as hard as they can. It's just not working for them. So obviously the brain is very, very complicated. When you guys read a book, this is kind of what it looks like for you. And that's why when you read a book and you go to the movie, you're like, wrong character. That's not how it should be. And I do a lot of dyslexia stuff all over the place that takes me, I drive there, and my wife doesn't want me to fall asleep in the car because I daydream a lot, and then I start sleeping and drive off the road. So she has me listen to auditory auto books. What? Okay, what am I trying to say? Audio books. Dang it. I've been talking too much today, so my brain is not parsing this information well. Listen to audiobooks, and one of the audiobooks I've listened to is Jack Reacher books. And Jack Reacher, there's a movie out, right? Have you guys read the Jack Reacher books? Yeah, pretty good books. My wife likes them because the bad guys always get what they deserve, right? In real life, guys can transport teenagers, have sex with them all across the place and say, no, that she's a woman. Crazy stuff. People are crazy. So anyway, she likes it because the person gets what they deserve. And what's interesting is if you read the book, Joyce has read the book. Joyce, how tall is Jack Reacher?
Say that again.
How tall is Jack Reacher in the book?
Oh gosh.
Short?
Short.
Oh, sorry. I set you up for failure, I guess. But in the book, Jack Reacher's 6'5". He weighs 240 pounds and he's got fast reflexes. Who plays him in the movie?
Oh, isn't it like Tom Cruise or something like that?
Cruise. See, that's what you're thinking.
Yeah.
Not that Tom Cruise is short. He's not short. He's average height because he comes up to about here on me.
Definitely short compared to the book.
Definitely short compared to the book. We're going to give, so when you read the book, you got all this stuff going on. You're thinking about what, Jack Reacher looks like. You're thinking about what he should do, plot, all those kinds of things is going on in your brain. And of course, we're going to give Tom Cruise a little bit of credit because number one, he's a really good actor. He's a good physical actor and he has severe dyslexia. So when he had to go for parts, he'd have stuff memorized because he couldn't read. When they're having people read for their parts, he's not reading them. They have to memorize all that stuff. So I'll give him a little bit of credit for that. This is from the Human Connectome Project. And this is, they're using DTI, which is a way to look at how hydrogen atoms move through water space. So you can kind of see where things are and they're going through the axons. So we can kind of get a mapping of the brain's axons, which is the whole reason for the Human Connectome Project, which is really, really cool stuff. Here's some reasons why when we're talking about reading acquisition, that it needs to be explicitly taught particularly something about this root that we've been talking about. And that is, when we're learning how to read, we have to hit up the left temporal lobe, the planum temporal, and Broca's area. And that's where we get to meaning. But as you read and read and read and read, you do what cognitive psychologists call automatic processing. You get to the point where it's automatic processing. And when you get to the point of automatic processing, you have to spend just a teeny bit of cognitive energy to do that task. And so where it in the beginning took what we call in cognitive psychology effort for processing, we just spent a lot of effort to connect all this stuff together. Now it doesn't take hardly any at all, and it jumps from graphemes to meaning almost instantaneously. This is what we call sight reading. You look at the word and it goes right to your memory. Now, we don't want to teach reading by sight memorization of words. That doesn't work very well. I mean, you'll see some kids in first and second grade who can't learn how to read through the mechanics of reading, phonological processing, decoding, synthesizing, recognizing the word, etc. They can't do that. So they do memorize all the words. And by third grade, they're really poor readers because that strategy is crashing on them now. They can't do that. But when you have overlearned it to get to the point where it's automatically processed, that's what you do as an adult reader who is a capable reader, is you go from word to meaning almost instantaneously. However, I should point out that research has also shown us that even as good readers, we look at nearly every single word on a page. Now, I don't know if there's many people as old as me in this group, but I remember as a high schooler, they were pushing the Evelyn Woods speed reading program, a complete abysmal failure. Yeah, people would turn the pages like this and they'd give them a test at the end, and the stuff they already knew they could answer, but the stuff that was embedded in the book they didn't know. They weren't reading. You can't read. That's not reading what reading is. Remember, imagine that you're talking to someone and they only, tell you like one word out of a paragraph of words. You have no clue what they're saying. Reading is when we're mapping on a written form of the language onto the spoken language. And as we hear and process each spoken word when we're communicating with someone, we're actually reading every word that we see on a page. We don't really skip words. Now, sometimes we'll look at it and we get really good at the right peripheral vision. And as we move towards those words, we jump kind of quickly over some of them. But the science tells us that almost every single word, we're doing a fairly decent job of looking at them just briefly. In fact, the movement between a word and another word is called the saccadic movement, or the moving of we fixate on something visually, and then as we move our eye, it's called a saccadic movement. And what happens when we are good readers they read like this. They skip, and they're quick at doing it. So if you really look closely at a person when they're looking, you don't see smooth motor pursuit like this. You see a bunch of this kind of stuff going on. And then you see them go down the next line. And even good readers, they go down the next line and they go like this and they go back up and reread stuff, right? That's pretty typical stuff. Poor readers, they fixate longer because they're not able to decode or synthesize very well. And then they go backwards a lot because they're not understanding what they're reading because they really don't do the mechanics of reading very well. So this has to be put in place. This is an arduous, effortful task. And this is from Stanislaus Donnie's work. And again, you get to hear it from the actual individual, absolutely fascinating. And I'm kind of asked him if I could borrow one of his slides because I really like it so much. But you can see here, and this is another amazing thing about the brain. Every square millimeter of our brain is developed and addressing some aspect of cognitive function. But in this part of our, the left fusiform gyrus, and it's there for facial recognition, which is in red, in tool recognition, houses, and other things that we recognize visually. But there's some things that the brain has left blank. These neuronal columns are just left blank. And I think that's quite ingenious because the brain is not only good at adapting, but it's saying, okay, we might have to do something visually that we didn't anticipate. So we're going to leave those blank. We're not going to respond to anything until we know what we're supposed to do. So a person who's a person who actually is reading well, these are words now, these areas now we're responding to words in the letter chunks and things. And so now there's only a few things left over for other things we didn't anticipate. But a person who didn't learn how to read, eventually that part of the brain's going, okay, go ahead, take over facial recognition, because I don't think I'm really supposed to do anything else with it. And you can see, again, there's a little bit left over for something else. As an adult, it becomes more challenging then to learn how to read. That's why we want to hit them up early on. And then the good news is that we can do this. We can do this right now. We can do this with 4-year-olds, with 5-year-olds. We can teach reading such that they'll get it. There truly is, I think, pretty substantial evidence that we can probably get 95% of kids to learn how to read, even those with dyslexia. If in fact 15 to 20% of the kids with if there is 15 to 20% of kids who have dyslexia, I still think that there's a good chance we can get almost every kid to learn how to read. We just never tried it. At least not since the 1920s. We haven't tried it. And it's going to take some effect to really change the system to make that happen. One of the reasons, this is from John Gabrielli's work, which is also quite fascinating. Here's a person without dyslexia. You can see the areas we were talking about earlier kind of lit up. There's some other stuff lit up because there's some attentional capacity that's required. But here's a person with dyslexia. You can see a lot of attention is going on. There's some things lit up for attention, but it's just not working. If we provide the appropriate type of intervention, which I refer to as the mechanics of reading, the phonological processing bit, connecting letters to the sounds we already know, teaching decoding, teaching synthesizing, and then that they can recognize the word they've pronounced as a function of that, and then to try a different pronunciation based on the letter schemes if we don't come up with a correct one or one we haven't really recognized, which, by the way, is why vocabulary is so important. But because if a kid reads a word correctly but doesn't recognize it as a word, oops, that's a problem. So one of the 5 pillars initially, although there's a lot more than 5 pillars, the initial reading panel of 2000, 5 pillars, vocabulary being one of them, is because if you decode, synthesize, and read the word correctly, but you don't know the word, then that's not very helpful. We need to also improve vocabulary when we're teaching reading, particularly for kids who come into school with a poor vocabulary. And for kids who come from environments that are diminished in some way, where there's not been a lot of parental input and discussion, they're going to have a smaller vocabulary. And we know how vitally important it is for kids to have adults speak to them with adult language construction, because they'll pick that up. And when they get to kindergarten, they'll have huge vocabularies versus people who think they should talk to the kids like babies. They'll have small vocabularies. If you use words, big words, that's helpful to kids. In fact, my daughter's a first grade teacher, and she has 2 kids. And when my grandson was 3, the other grandmother said, "Carter, look at this. This is a cocoon, and someday a butterfly is going to come out of this cocoon." And Carter's a 3-year-old. I swear this is true. As a 3-year-old said to his grandmother, "No, G-Ma," because that's her name, G-Ma. "No, G-Ma, butterflies come out of chrysalises." It's ridiculous. I told my daughter, if you don't knock it off by the time he gets in kindergarten, he's going to be a disaster. And he does know a lot, but she really fooled him. She put him in a Spanish immersion classroom, so he didn't know anything. Oh, pretty interesting. And so if we give the correct form of intervention, or if we teach kids with the appropriate type of curriculum, look what happens. After the intervention, they now look more like a kid without dyslexia than they did prior to that time. But we have to do the proper type of intervention or curriculum. We have to teach the alphabetic principle, that letters represent sounds, how to decode them, how to use the mechanics of reading. We'll teach kids how to read. And I've seen kids that, we saw a kid from California that visited our center. And I told the mom sitting in that chair behind me over there, and I was sitting in that chair over there. I told the mom, this is the worst case of dyslexia I've ever seen. He had repeated kindergarten twice, was about ready to repeat first grade again. And I said, it's going to take a year before we see any traction. But because of the way we construct our intervention program, and granted, I was surprised by this. And I also had my son do the intervention, who's a school psychologist who was moving from one position to the next. And I said, hey, would you like to work with this kid? He's got real difficulties with reading issues. And he said, yeah. By Wednesday, he went to Walmart with his mom and he looked up and went, whoa, look. And he started, that's the mechanics of reading. We were teaching him small bits, but he could do that little bit. And the mom just started crying because like, and she came back there, dude, I thought you said it was going to be a year. Yeah, well, predictions aren't always accurate, are they? So, and that was in the summertime. He was here for a week and a half, and then he came back again. And then by Thanksgiving break, he's actually reading very short chapter books. Will he always be a struggling reader? Yes. Will he also take longer to read books? Absolutely. Should he have an accommodation when he's in school? Yes. Should he have a diagnosis of dyslexia even though he can read a little bit? Absolutely. Because when he takes the ACT test or the ACT, will he have accommodations to get longer to take that test if he doesn't have a diagnosis of dyslexia? No. Is that fair to that child? Absolutely not, because he probably knows a lot more than other people who can read faster than him. He just can't show it. And Renee's shaking her head because she knows what I'm talking about. Because if you get accommodations for time and a half, all of a sudden that kid's ACT score goes from 19 to 28. And you're like, what? That's what we're talking about. You know, we got to give them the tools to be successful. Because when they're in college, do you think a college professor is going to grade them on if it took them 2 hours to read a chapter or 4? Nope. Do they care? Even less. All they care about is what they're learning. In the workforce, if they take their work home, are they going to care? No. So, yeah, and Stephanie said her daughter's score jumped 10 points. We got to have that. I mean, there's so much we know today. I mean, really, we've actually seen kids here. We told them they had a diagnosis of dyslexia. They're like, oh, thank goodness. I am smart. I know what I'm talking about. I just have a problem with reading. I get it. So the last thing I want to talk about, maybe talk a teeny bit about what's going on in Kansas with our, what happened with the legislative task force on dyslexia. Just briefly give you a little synopsis on that. But why is it so difficult to learn to read? Well, there's different types of writing systems. The first thing, you guys know the alphabetic principle. It's understanding that letters represent speech sounds. I mean, that's why the alphabet, and I could tell you how it all happened when, people didn't know how to write and they just put scratches on clay pots to say what was in them so they could do commerce and they know what people owed each other. And then they're like, yeah, but we got different things in there. So we'll draw different pictographs. So things in there. And they're like, well, then you need to sign your name to say that that's in there. Well, now you need to do it. So they then had pictographic types of languages. And then they came up with this, hey, let's put a letter to represent the sound. And then we can create any words with just a few bunch of letters rather than have a picture for everything we got to draw. Brilliant, right? Absolutely brilliant. The alphabetic writing system is brilliant. And the nice thing about the alphabetic writing system is once you understand the relationship between the letters and the sounds, you can read anything, even words you've never seen before you can read, which is incredible, right? But you got to know how to use those. And that becomes a little bit of a challenge. So you also have to understand that there's a predictable relationship, because if it's not predictable, then it doesn't work. Nothing in learning, if it's not predictable, you'll never learn anything unless it's predictable. It won't make any sense to you. If one time it's this way and the next time 2 + 2 is 5, that's a problem. So this knowledge is critical to learning how to read. No doubt about that. We have what's called we don't have what's called a transparent writing system. And a transparent writing system is one where there's a one-to-one relationship between the letters and the sounds that are used to represent them. So when I'm talking about mapping on a written form of language on top of a spoken one, it's almost like it's transparent. You can kind of see through it. So those letters and sounds are kind of like transparent. You're right there. there's a number of examples: Spanish, Italian, Greek. There's a number of them. Some Scandinavian languages. I can't think of the one right offhand. We're always compared to this particular Scandinavian schooling system, and they always say that, you know, how superior they are to us and blah, blah, blah. But one of the reasons it's really a lot easier to learn how to read in. What am I thinking of? Finland. That's right. Thank you. I don't know how I could forget that, but sometimes I do. But yeah, Finnish is one of those transparent writing systems. Danish is not. So it depends on the Scandinavian, language. And so in those transparent writing systems, those kids learn how to read later than our kids. They start learning how to read later, and they're done sooner because that connection is pretty simple. You know, those of you who speak Spanish, super simple, right? Spanish is also a very efficient language in the first place, and the writing system is extremely efficient. So with the Spanish system, nearly every letter represents a particular sound and only that sound, and that sound is only ever represented by that one particular letter. So I mean, it's beautiful for them. But an opaque writing system like the English writing system, although it's not impossible to learn how to read, because we've all learned how to read, but it's still more challenging than a transparent writing system. So there's 44 phonemes in the English language, or 43 depending on where you are. There's only 26 letters. So it makes it a little bit of a challenge, because like other languages, we don't have diacritical marks where they do. Some letters represent several sounds, right? My favorite is a long E sound, although all the vowels are kind of the same way, but you got E and EE and EA and E consonant E and Y by itself and IE and EI and EY and I by itself. It's crazy. We're teaching little kids this. Like, this is really easy. It's not. It's way more challenging than Spanish. You got the letter I, that's E, that's it. You got the K sound, can be C like in cat, like K is in kick. You got CK like in kick, you got CH like, other, in that QU. So sometimes in the same word, like quick, QUICK. About 200 years ago, there was a movement to standardize the English language and make it more like a transparent writing system. But they said no. If they woulda, we wouldn't be talking tonight. But they didn't. And then you got G and J. Jello is JELLO, but if you're going to gel, it's GEL. Giraffe, gaff, you know what I'm talking about. And then we got digraphs. So we teach kids that the S sound is a S, H sound is a H. So SH should be ch. No, it's sh, an entirely different phoneme. Just makes it more challenging, right? And then, of course, my favorite, I love R controlled vowels. I love them. And of course, of all the R controlled vowels are the sounds, because it be ER, IR, or UR. I like it. But this is also the beauty in terms of the English writing system as well. We have multiple words that are homophonic words. They sound exactly the same, but they mean different things. But in the English writing system, even though they sound the same, we write them differently, so we know that they mean different things. So if we're reading a story about FIR, we know it's about a plant. If we're reading a story about FUR, we know it's about animal hair, which is fur. It's not hair. And then once we get all that acquired, we've got alternative spellings. And of course, the 5 languages that contribute to English, hey, we let them come in here, no problem. And we let them retain their writing systems. Like French is also an opaque writing system. German's not. So, and then we got homophones. I love the homophones. But like I said, the way they're spelled helps us understand about their meaning. So, do we need a cup of flour or a cup of flour? It makes a difference. If you're making cookies, which one you use. And this is my grandson. I gotta show you him for a second, because I already told you that my daughter put him in and this is, he's in second grade now. So this is when he was in kindergarten. And of course, since my daughter's a first grade teacher, she taught him how to read when she wasn't supposed to. They're not supposed to learn how to read English until third grade, but she taught him how to read English, how to read the English writing system in kindergarten. And so in spring break of kindergarten, we're driving down the road and Carter says, "Opa," that's me, I'm Opa. So my wife was born in Germany, and he had both sets of grandparents and all but one set of great grandparents. So all these grandparents, he had to have different names for them. And so he said, "Hey, Opa, I can read in English and in Spanish, but English is tricky." Here we have the root of it. A kindergartner figured it out. We have people in colleges of education that don't understand this. We don't have to teach the mechanics of reading. We can just teach the 3 cueing system. That's perfectly fine. No, it's not. The kindergartner says, no, it's not. And a bunch of his friends were figuring this out too in first grade. Hey, this English, what? It's kind of crazy. So what's the good news? The good news is science has provided the answers. We know what the answers are. We've got work to do, not saying we don't, but we started the Center for Reading after a decade and a half of our own research. And we've been working with kids since 1996, helping them become competent readers. And we had a kid from Switzerland come over, and in Switzerland, they speak multiple languages there. They teach a lot in English. So if he'd have been learning to read in German, he wouldn't have come over here, because he'd have been a slow reader, not a non-reader. But he learned how to read in English, and so he was a horribly challenged reader. And he came over here, and we taught him how to read. And I'm only telling you this story because we've got the answers. We've had them for a long time. And we found that Joel got accepted into a doctoral program 2 years ago and is going to study neurology. So we're taking a teeny bit of credit for that because we taught him how to read. Now, that'd be a really cool human interest story. And I'm friends with him on Facebook and said, "Hey, Joel, would you be interested in doing this?" He's like, "I quite frankly don't remember what I did in third grade. So darn it." So we know there's interventions to help people become competent readers. We know there are programs that prevent reading failure. In fact, we have a program here called the Secret Codes Curriculum. And the Secret Code teaches kids in kindergarten how to read by the mechanics of reading. And the school systems that have used it as a kindergarten reading curriculum have actually seen their reading failure rate drop to under 5%. And we had a teacher in Oklahoma, was a first grade teacher, and for some reason, the last like 5 or 6 years, she had 80% of her kids were not reading at the first grade, at the end of first grade, and she was about ready to pull her hair out. And actually, she told me she considered quitting. She says, "I don't know what to do. Do I put them on to second grade, let the second grade teacher figure it out, or do I retain them, or what do I do differently that I didn't try already? Because I've tried everything." She said, "Can you use your curriculum?" I'm like, "Of course, that's why we wrote it." The first year she used it, she went from 80% to 0 failure. The second year, 0. The third year was last year. I don't know what was going on last year, to be quite frank with you, but I'm guessing probably 0. And educators like you care, and you're willing to learn this new information that you weren't taught when you're in college, so that you can help kids become competent readers, because that's what you want to do. That's what you signed up for. You wanted kids to be competent readers. So just briefly, you know that in government, we have 3 branches, right? The executive, the legislative, judicial. That's at the national level and state. So at the state, we have governors, the executive, the legislator, state legislature, and the judicial. You know what's really cool in Kansas? We got a 4th. Hardly anybody's got a 4th, but we got a 4th. It's called the Department of Education. And the Department of Education can lay down the rules and everybody's got to follow them. Legislators, they can say what they want, but it doesn't really matter. Or they can say, "You guys need to do this." The Department of Education says, "Thank you, we're not going to do that." Now, they usually get along better than that, but in the last few years, not so much. So the Legislative Task Force on Dyslexia, 3 major goals that we wanted to accomplish, actually 4, but the 4th one involves legal issues and probably not as pertinent to what we're talking about. But the three major goals is number one, like almost all states, there's 44, 46 states right now working on or have passed legislation in terms of dyslexia because IDEA is not really working for kids with dyslexia. They talk about dyslexia. In 2004, they put the term dyslexia in IDEA. So when school systems say, we don't have to say nothing about, don't have to say anything about dyslexia, they are 100% incorrect. Dyslexia is actually used on purpose in that piece of legislation. You can go look it up. It's in there. DYSLEXIA, dyslexia. It's in there. But it's really not working so well because they'll say, oh, IDEA requires FAPE, free appropriate public education. We've got the mechanism. It's not working. It's not working. How we know that? Because 33% of our kids are not learning how to read. So if it's not working, what else do we need to do? So number one, like Missouri a couple years ago passed, you're going to do early identification and you're going to train teachers for 2 hours in service a year on dyslexia. Like you guys know, that's enough, isn't it? But it gives them a little taste, right? Gives them a little taste. Hopefully that gives them a taste to want more. That's what I would hope would happen. But so, okay, you do early identification because you're required to do that. Then what do? Hey, your kid's got dyslexia. They're going to have reading failure. Well, what are you going to do to help them? Don't know. So that's not sufficient. So the second thing that the task force suggested to the Department of Education, Kansas Department of Education, was got to come up with curriculum and you have to come up with interventions to help kids who are struggling readers or who are at risk for struggling at reading. That was number two. Number three, which was my subcommittee, was what do we do about educating the pre-service and in-service teachers? And so what we wanted to have happen was for Kansas to adopt new standards to teach pre-service teachers how to teach reading. And those new standards would be incorporating the knowledge and practice standards of the International Dyslexia Association. Are they perfect? No. Are they better than what's out there? Way better. Absolutely. Way better. And then number two, to be licensed as a teacher in Kansas now requires that individuals pass a knowledge of reading test, knowledge of the science of reading test. Now, we don't know what that means. The Department of Education is going to determine what the pass rate is or what the pass number is. But that ensures two things. One, the person who becomes a teacher is knowledgeable to some extent in the science of reading and the mechanics of reading. And by the way, the science of reading is not a procedure or method. The science of reading is everything we know about reading. But we have to say the science of reading because everybody says stuff that's not true. So we have to say the science of reading. It's physics. We don't say the science of physics. We already know it's a science, right? We don't say the science of biology or the science of psychology. We just say those words. We can't do that in reading because reading, people have jumped down rabbit holes, all kinds of crazy notions of how to teach reading. Look at the whole word and just guess at it. That's not going to teach a person how to read that's based in an alphabetically based system. It doesn't going to work that way. And so the Kansas Department of Education is writing the standards that the colleges of education have to abide by to be accredited to teach teachers, and the teachers have to pass the test before they can become teachers. So that's going to start solving some problems. Will it solve it immediately? No. But those are the three big things that the Kansas Department of Education has adopted and is putting into place so that in the future, anyone who teaches in the state of Kansas will be knowledgeable in the science of reading / mechanics of reading, and colleges of education will be accredited based on their ability to do that. So what questions do you have? And I guess before people start peeling off here, because probably the basketball game is getting interesting for people. Although for me, quite seriously, this is way more interesting. I'll sit here and talk to you guys until the basketball game's over. I don't care. And I think basketball is pretty cool, but this is way cooler. All right. So if you want to peel off and do something else, if you want to contact me, the DP Hurford at pittstate.edu, I do respond to email messages. And if I don't, because Tiffany knows I do, I will respond. But if I miss it, you need to, probably the next day or something, respond back and say, hey, you may have missed this. I'm not offended when people say, I think you missed this, because I get hundreds of emails a day. Granted, 60% of it's just stuff I can delete, but I still have to look at it and delete. So sometimes it gets buried, and sometimes really important stuff, then I don't see it anymore. And I'm like, uh-oh, it's not there, So I am interested in, developing a relationship with you guys and helping answer questions or doing whatever is possible. I generally don't get on the Facebook page because I'm on several of them that are the same thing I didn't learn in English, and it gets pretty nasty at times. The one in Oklahoma and Arkansas is like, you know what? I could yell and scream and waste my time doing that, or maybe I could do something more beneficial to other people. So that's what but if you have a question, I'll try and answer, but I know people will argue with me, and that's okay. I really am a student of the science of reading. I've got a lot more to read and understand. So I can learn by strategies that you guys are using too. So if you want to share some of those things with me, I'm cool with that too, because our goal is to help kids become competent readers. I don't care if you use my methods or someone else's methods. What's important is kids get to learn how to read. Because as you know, when kids don't get to learn how to read, it damages them. And it damages them not only psychologically and emotionally, but it damages them in terms of their potential future salaries. It damages them in this country, our health insurance, our ability to access healthcare is tied to our ability to be employed at a level that our employers will give that to us. So a lot of things, there are like 60 million adults who can't read their prescription bottles well enough to actually take their medication right. So we got a lot of stuff to do. We definitely do.
We want to thank you so very much. And I want to thank you as well for just being part of that legislative task force, because I know Cindy Hadeke and yourself and those with knowledge have moved us forward, and we're so grateful for that as well. So we really appreciate your time and knowledge, and we're so excited that you're giving us your information and letting us reach out to you as well, because we're all trying to grow together, and like you said, what's best for kids and helping them become literate.
Well, thank you, and hopefully we'll communicate again soon.
Yes, thank you. We appreciate